Alright everybody, this is a whole different type of video for me. Most time I just do fishing and hunting, but we're going to do something a little different today. I am very lazy at heart. I try to work hard and do fun things, but I want them done the easiest way possible. And I've been wanting to put a trolling motor on my kayak. It's a 10-foot Sun Dolphin. It ain't nothing special. It's the cheaper end of it. But it works well and does what I need it to do. I'm just lazy and get tired of paddling it around. And all these trolling motors you look at, they're really expensive, or they're really heavy, and they're not made for smaller kayaks like this. And I'm just cheap, and I wanted to make my own. So here today, I'm going to show you guys what I've done. I have taken a drill motor, which you have probably seen by the title, a Craftsman little drill motor, I think it was a 12 volt originally. And I have wired it up now and ran the wires down through the kayak back to a control unit that I'll show you. And it works really well. But I took it out the other day. I was a little anxious and wanted to get it done, and I wanted to try to do it off film to make sure my work was done right, and it didn't work so well. It went for maybe 100 yards, worked as well as it could, forward and reverse, everything worked fine, but then it started blowing the fuses on me. I have a 20 amp system with a 15 amp fuse in it. I figured the motor that I had in it at most would maybe pull 10, and I'm not sure what happened. So I'm not sure if something got wet in here and it stopped working, and I'm not sure. I keep saying end a lot too, and that's just not going to work too much, but we're going to get through this, people. This ain't my type of video. But I'm going to show you guys everything I have here and what I've done. I have a container here with the trolling motor down inside of it. I'll get you a better view of it, and we're going to fill it up with water and let it run. So you guys will get to see it run because it is working right now, and it'll turn on. Yeah, it's working right now, so I'm guessing everything's dry and it helped it out. We're going to find out. We're going to soak it in the water and see what happens. So why don't you guys stick around here. Alright guys, so we didn't even get to do the water test. I mean, that camera's up too high. I don't know what I'm doing, guys. I'm new to this. I'm new. I don't know what to do. If you don't get that reference, I don't know if we can be friends, but we'll try. Alright, so we're going to bust this thing open. It started blowing fuses even before we got it into the water, so that's a good sign that it's not a water problem, a motor problem, and that's a little easier to fix. But this will be the first time I've seen it since I filled it with spray foam. I haven't busted the seal on it since. And this will be the first time that you guys get to see the inside of this thing. So this is how you rebuild a trolling motor, put a drill motor in it because you're cheap. And this is what it'll look like. Woo. It did a pretty good job. Except for it don't look like it's holding it. It for sure looks like it's been spinning in there. Here, we'll see if we can't get you guys a little better view of this. So that's it right there. That's the back end of the drill motor. I filled it with spray foam as the shadow's not helping at all. Man, I'm not good at filming by hand. That's why I put it in the stand. But I filled it with spray foam, and you can see it's been turning inside there. It's cut itself a pretty good clean groove right around the whole side of it. So I'm guessing the wire from up here down in has ripped somewhere, which sucks because that means I got to try to rewire around all this spray foam and everything. I thought that would be the fix, but we're getting ready to try it out, and we're going to bust this other side of it open and see what it looks like. So that is the inside of it. Like I said, it is pretty well rounded out. It's been eaten up and spinning on the inside, so I'm guessing somewhere from here up into the top of the shaft, because I have this taped off pretty good, that the wire's ripped. So we're going to try to get this seal off without messing this motor or anything up. Don't want to rip the seal down here. Ugh. Woo. trolling motor. Oh yeah, right there it is, guys. I know this is going to sound a little crazy, but I'm glad this happened and not anything else, because this is fixable. But if you can see, come on camera, this camera's no good, guys, but them wires ripped right there. So that lets me know it was spinning on the inside and they started touching each other. That's not that bad of a fix, but we're going to try our best to fix it. And I think I'm going to try to design something to go around this. I am no good at filming like this. We're just going to leave the camera up here. I ain't no good at trying to move this thing around, but it did. That's what it was doing. It was spinning on the inside, so as this shaft was spinning, the wire was getting twisted up around it, and it ended up ripping and tearing into them, so it was throwing a short on itself, which is okay by me. So we're going to get this spliced out on tape this top. We're going to run some new wire in it, and I got to come up with a way to get this to hold inside of here without tearing itself up. I don't think it should be too hard, but I thought spray foam would work, and as you can tell, it did not. But that's all right. This is a learning process, and we're trying to figure it out one step at a time. So that's what happened there. That's the bad section of it. Is that thing just took it and wrapped it up around itself and ripped the wires into themselves, and that was the end of that. Which is kind of weird because it worked yesterday. And earlier, you guys seen it turn on there before I stuck it down in the water. That's why I thought it was shorting out in water. So, we're going to try to find a way to make sure this doesn't move inside that housing unit of the trolling motor, because everything else seems to be working fine. It's just, it keeps binding itself up, which is really weird. I don't know. I have a hard time imagining that motor puts out that much torque, but it just keeps showing it does. And the little bit of time I had on the water with it, it had this kayak moving faster than I ever paddled it. So we're going to get this all buttoned back up. We'll still do a water test if we can. Alright, so that's our problem. I got it wired back in there, and I got to find some electrical tape, put around this. And like I said, I got to come up with an idea that's going to hold this from being able to turn on the inside. And I'm trying to come up with a different idea because I just don't like this one, but I think it would work. That's the problem. Then again, I thought the rest of this shit would work, or the rest of this stuff would work too. But this will slide over top of this, and then I'm thinking about getting a piece of wood or something, like a piece of plywood really thin, and taping it across here. And the two main screws that come up through, but we can get these two main screws then that come up, run the inside of it, and then I figured it would hold to that. So, might be worth a try, might not be. I'm not exactly sure yet. But then it would be able to spin a little bit forward, a little bit backwards, and then it would hold itself. And this is the problem when you're taking an old idea and trying to make something new out of it. It was designed to spin freely like that. And now I'm trying to stop the motor from spinning, but having the shaft spin. So, we're going to figure it out. Hopefully at the end of this video, like I said, we do a water test and we get to see what it looks like. Not used to this, guys. I forgot to turn the camera on, but we got that taped up. We're going to get it, figure out which way it wants to lay here best. Probably back. And then we're going to try to figure out if we can't cut a piece of wood. I think that's the best idea I got. Alright, I kind of came up with a better idea maybe, because the wood just wouldn't work. I wouldn't be able to round it right. So I've taken a nail and bent it over pretty well, and it sits. I don't know how well it shows it. Try to do it like this, I guess, because it ain't working. But it's going to fit right on the inside there. And that should be able to catch the two bolts that run up through it and keep it from turning all the way over. If it turns some, hopefully this don't ruin it, and we'll try again later on in life maybe and fix it or make another one that's better. But for now, this is the idea I got, because I don't know how well the camera shows it, but there's the two holes for where the bolts will be, and then that screw, or this nail, if I could daggone thing, it fits. I promise, it fits right over top of those two and down the canister. So hopefully this is going to be the fix that we need to get this going right. It fits pretty nice. I mean, it's stiff. I think I got it set just good enough. It's not turning now. I'm having trouble turning it by hand, so we'll run these bolts up into it. It seems really stiff, so that's the stiffest it's been. I used to be able to turn it by hand, and now it's holding the sleeve. It's turning the bolts with it, so all I can really do is hope on this. This is all learning to me, trying something new. This is always the worst part about this. I've only done this a couple times because I hate doing it so much. But trying to line these bolts up to this cap are just a hassle. But I say that now, and they'll probably go in easy as can be, so. Well, that one took. I lied. Neither of them took. Not even that first one. It felt like it did, though. We might have got it. I know I was standing in your guys' way for that success, but it was a hassle. And I think we got it. When in doubt, pull the hammer out. Well, a mallet. With all that spray foam and stuff in there, I just want to make sure it gets a good seal. At least the best chance it has. Alright. I'll put a piece of tape over this so we can see it a little bit better. There's a little piece of tape on it there, so maybe we can see it a little bit better. You guys might be able to see it. Close the door behind it, give it a nice little backdrop. But it's all put back together. The wiring is somewhat summed up. I'm going to actually leave it kind of loose here maybe just to see if it pulls on it. Well, We got it somewhat taped up here. Hopefully the wire stays out of the way of everything, and we're going to give it another test pull. Well, it's working again. It's not spinning. Seemed to have spun a little bit and then locked up like it's supposed to. We might have got it here. Pull his tape off. We'll put this propeller back on and we'll do the water test, see how it does. I'm a lot more confident now that I know that it didn't get water in it, because I was scared that I messed with the seals too much. Because all I do is take a regular drill with a chuck on it. I cut the shaft off to length to where the chuck just fit up against the front shield at the rubber seal. So it's just a trolling motor shaft cut off onto a drill motor. That's all this is. So I'm really cheap, and I didn't feel like buying an expensive one. I mean, they're almost $200. You get a nice one. I'm sorry, I am really sweating here. I don't mean to be showing my belly off, but I'm just a cheap ass. That's really all it comes down to. And I wanted to find a better way to do this and make it a little bit lighter. And putting that smaller motor in here, like I said, this thing has dropped almost half its weight with the mount and all attached. So just from the motor and shaft to having the whole housing unit, and I'm not good with boats, whatever you want to call this. It's at almost half its weight than what it started. So that motor was really heavy inside. And it don't seem like you need a motor that big to push this much power. So let's get the propeller on and put it in the water. This is all new to me. So, and I think I just snapped that little plastic bolt or nut. Test number 2. That's 100%. That little thing is getting it. And it's very well balanced. I don't know how well that camera shows it, but it's not flopping all around. It's very well balanced. And with its speed controller on it, I mean, I can run it very slow. So I can adjust my speed at whatever I want. Let's put it in forward. I mean, it's pushing air off of it, so that must be all right. Well, I'm going to get the chair back up here. We're going to put the tub here. We're going to fill it up with water, and let's water test this thing. I want to step you back just a hair bit more here. Maybe that'll help the view. But like I said, the control panel and all, I bought everything off Amazon, and the drill I had laying around. But I priced the drill right at $60 nowadays. That's about what those ones are kind of running. And the control unit, the speed controller, cost me $20, and the wires cost me right at $16. So if you got an old trolling motor laying around, it does not cost that much to build this unit yourself. Don't get me wrong, if guys don't want to do it because it's just easier for them to buy a brand new one, it's fully understandable. Alright, I think that's going to do it. Let's get this thing running, see how it's going to go. And I will name up the percentage I have the motor running at as it's on. We're going to start at 0 and work our way up to 100. And this is in forward, I believe. That's 10%. That's 20. That's 30. That's 40. 50. 60. 70. 80. 90. 100. That was 100% there at the end. That thing is really moving some water, guys. Oh, I would love to be able to test how much force it's pushing, but it's got to be more than what that motor originally ran at. And it was a 15 horsepower motor is what it was. Now we're going to try this in reverse, see what it does. Make sure we're locked in. Pretty good. It's not twisting on itself. Maybe that little nail in there is working. Nobody really knows till it breaks again, because I'm not going to tear into it. Yeah, I broke that little plastic nut. It's allowing that propeller to come loose a little bit. So I'm going to have to fix that here in the future, but I don't think that's going to be that big of a deal. Forward again. That's only 30% right there. That is pushing some water. That's 50. That's 100. I'm trying to figure out if it's going to twist in there or not. I'm trying to break it while we're here. This is just awesome, guys. It is working very well. Put it back in reverse. See if we can't get it to twist in reverse. That's just working fantastic. I really couldn't ask for anything better on this. I know, guys, it's not on the lake yet. We're gonna take it out later on, and I do hope you guys come back for that video. But I think that's gonna wrap it up for today. We got everything in. It seems to be working great, and I'm just excited to take this thing out on the water. Especially when you build it yourself, it just makes it that much cooler. And I don't know if I told you guys this or not, but this is all running off a Ryobi battery. And it's nothing big, it's just a little one. 18-volt lithium battery. Had this running outside of a load for an hour and a half, 2 hours, and it was still going. I actually had to go somewhere, so I unplugged the battery. And this one doesn't have a tester to tell you how much you used, but after 2 hours, that's pretty good. If I get 15, I figure if I get about 45 minutes to an hour of travel off of one battery, I'm doing really well, because I can pack extra batteries to go along. That's not that big of a deal. So this is just turning out to be such an excellent little toy and fun thing to do. I'm just enjoying it so much. And I hope you guys come back for the next video to check it, to go out on the water and everything, because we will be making one. If it breaks or if it doesn't matter. We'll be making a video about it. If we sink the boat, I'd hate to have that happen, but it would be really good clickbait. So you guys come on back, and we'll see you on the next one. You have a good one.